Alright, welcome back everybody. In this video we're going to look at example 2 for finding exact area using RRAM. I'm not going to even bother to draw a sketch here now that we've got the general concept laid out. First off, we need to find the width of a rectangle. The width of the rectangle is going to be based off of the width of this interval, and we're subdividing this width interval into n rectangles, so the width of each rectangle is going to be 2 over n. And then we need to find the value of the function at the right endpoint of a few rectangles. Okay? Now since we're starting at x equals 0, the right endpoint of the first rectangle is going to be at 2 over n. So we're going to substitute 2 over n into this function. That gives me 2 over n quantity cubed plus 2 times 2 over n quantity squared minus 2 over n plus 2. And that's the value for the height of the first rectangle. And then the second rectangle will be at 4 over n and we'll add up all the rectangles all the way up to the last rectangle, which happens at 2, which I'm going to write as 2n over n. Okay. Now that I have that, I want to convert this over into a summation. And so this is going to be 2 over n times the sum from 1 to n of 2k over n quantity cubed plus 2 times 2k over n quantity squared minus 2k over n plus 2. And there's our expression representing the area for n rectangles underneath this curve, which I now need to do a lot of manipulation of. It's going to be the sum from 1 to n of 2k over n to the third plus 2 times the sum from 1 to n of the quantity 2k over n quantity squared minus the sum from 1 to n of 2k over n plus the sum from 1 to n of 2. Now I want to simplify all of these things and bring constants out in front. And so this is going to be 2 over n times, when I expand the quantity 2k over n to the third power, it's going to give me 8k to the third over n to the third. The 8 over n to the third is constant with regards to that summation. So I bring that out in front. And let's see, that's going to be 4k squared over n squared. So I'm going to go ahead and combine that with the 2. That gives me 8 over n squared. And I can bring the 2 over n out in front here. And then I'm going to evaluate all of these summations using my rules. So we've got 8 over n cubed times, this is the quantity n times n plus 1 over 2, the quantity squared. So when I square that, that's n squared times n plus 1 squared all over 4. This is n times n plus 1 times 2n plus 1 all over 6. And this is n times n plus 1 all over 2. And this is just 2 times n. Alright, now I want to distribute, and I'll do my little denominator switcheroo along the way. So I distribute it through the first term right here, and that gives me 16 over 4, which is 4 times n squared times quantity n plus 1 squared all over n to the 4th. And I distribute it through, and that gives me 16 over 6, which is 8/3 times n plus 1 times 2n plus 1 all over n to the 3rd, minus, let's see, 4 over 2, that's 2, times n plus 1 all over n squared, and plus 4. And now I want to take the limit of this whole thing as n approaches infinity. Alright, so the limit of this as n approaches infinity, the largest power when I expand the numerator is 1 n to the 4th, so that limit's just going to be 1. The limit of n times n plus 1 times 2n plus 1 all over n to the 3rd as n goes to infinity is going to be 2. The limit of n times n plus 1 over n squared is going to be 1. And now I'm just going to add all of these up. I've got 4 plus 16/3 minus 2 plus 4. Let's see, that's 8. That's 40/3 minus 6/3. That should all add up to 34 over 3, which is going to be the exact area underneath this curve from 0 to 2. Alright, that's the end of this video and the end of the lesson on finding exact area using RRAM. Lots of practice ahead for you guys to help you make sure you get really good at this kind of manipulation. Okay, see you guys next time. Have a great rest of your day.